Hello everyone, welcome to section 7.6. We are now talking about the second law for oblique triangles, the law of cosines. So remember in 7.5 we covered the law of sines, and we have these four different types of triangles. The angle, side, angle, that's not a highlighter. The angle, side, angle, 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 side, side, angle, side, and side, side, side. So we used, oh, we're missing one. And obviously the angle side side, right? We use the law of sines for all of those, and for the two left over, the side angle side, and when we have only three sides, we now use the law of cosines. Now, all it comes down to, you'll see here that there's three different equations, and people will be like, oh man, I gotta memorize all these. No, you don't. If you know one of them, you just substitute the variables for where they go, and you'll see that it's the side you are solving for squared is equal to the two sides that you have minus 2 times the two sides that you have and the angle you are solving for the corresponding side. Those things just get swapped around. You'll see B replaced A replaced B, A replaced B, right? Like the more you use them, you don't have to memorize all three of these. They just sort of adapt and adjust. Now you'll see at the bottom of this page, there is an example again of where did this equation even come from. And I like to go over these. I don't expect you to memorize these or necessarily be able to do these, but I like to show you that everything, was found using mathematical logic. So if you just look at the triangle here, right, the oblique triangle, you think back to section 7.4, we've created this, dropped a perpendicular and created a height. And we've labeled our distance on the bottom of x and then c minus x, right, because this is side length c. And we've calculated a few things. We've calculated b, using the Pythagorean theorem. B squared is h squared plus x squared. And what we did was we instead isolated for the height. And you'll see here's your first. So height is actually b minus x. And then we took the other half of the triangle and did, well, a squared is equal to h squared plus c minus x squared. And again, we changed it to isolate h. Again, why do we do that? Because we can set them equal to each other. We did that in section 7.4. So now you have that this equation is equal to this equation. You do some algebraic manipulation, some foiling. You work your way down all the way to here. A squared equals b squared plus c squared minus 2cx. Now, a squared equals b squared plus c squared. Look, right here. A squared plus equals b squared plus c squared. And then you have minus 2bc, but here we have 2cx. So that means that minus 2bc cos A comes from this minus 2bc, or sorry, not bc, 2cx. Right? That's what we have in the equation here. And this is what we have in the equation that I just showed you above. Well, that means that here's a c and here's a c. That means x somehow becomes b cos A. Well, if we look at our triangle up here, right, x is right here. And x is equal to cos 50, right, or cos A. But cos 50 is equal to x over b, which means x equals b cos 50. Or in this case, to be more generic, b cos A. And it gets filled in instead of the x in the equation to give us that. So that is how they came about the cosine law, right? Using that oblique triangles. And this is your example of one of your equations for cos. If you're going to solve for side B or side A, you just rearrange the letters. If it really freaks you out, just relabel your triangle so you're always solving for side A, right? Like you don't have to worry about this memorization piece. Now there are two very important pieces here with cosine law, and it's this right here. When you have a side triangle, you have to solve for the largest angle first. Now, I'm not 100% sure the reasoning off the top of my head here, but it has to do with reference angle kind of information. That if you don't solve for the largest angle first, and you solve for the smallest, you end up actually getting wrong answer. So solve for the largest angle first. The beauty here is there's no ambiguous case in the law of cosines. So here we go. We have a triangle. Right away you identify, okay, I have side, side, side. So I'm going to draw this thing. I want to try to be as straight line as possible. So boom. Let me just try that again, one sec. Boom, boom, boom. Okay, so there's my triangle. Now, you can see that A is 5, so A is the smallest side. So I'm gonna put a 5 there, and then B is 7, so there, and then C is 10, because that looks about 5, 7, 10, which means that my A is actually over here, my B is over here, and my C is up here. But what matters is I need to solve for my largest angle. So I'm solving in this case for C. So my equation, C squared, is A squared plus B squared minus 2AB cos C. Now obviously I've used this a lot, so I don't have to flip back and look, but think about it. This is the side I want, so it's the angle that I have. This is the angle that I want. So I'm going to use the side, right? And then it's the other two sides, the other two sides. The more you do it, you'll be like, oh, okay, pattern, pattern, pattern. It all makes sense. I get it. So now this is simply, you can do the algebra at the beginning or you can do it at the end. Might as well do it at the end. Plug in the info you have. So 10 squared equals 5 squared plus 7 squared minus 2 times 5 times 7 cos C. So 100 equals 25 plus 49 minus 70 cos C. 100 equals 74 minus 70 cos C. Subtract 74 from both sides and you get 26 equals negative 70. Don't forget that negative, right? Cos C. Divide both sides by negative 70 for cos C. And now you go inverse cos of negative 26 over 70 is equal to angle C. And here's where the reference angle piece comes into play, because if you look here, you have a negative number, which means for cosine, remember, you're going to be over here or here, which is why you're going to get a bigger angle. If we solve for the smaller angle first, it would throw off our reference angle. So that's why this happens the way it does. Now, finishing this question up, you get that angle C is equal to 111.8 degrees. And this is greater than 90, so you should be like, okay, I'm pretty comfortable with that, 111.8. Now you have an angle, you have a whole bunch of sides, you can use sine law to fix the rest. So it doesn't matter which one you solve for next, you can use either one. So I'm going to solve for B, so now I have sine of C over C equals sine B over B. Bit of algebra. Sine B equals 7 times sine 111.8 over 10. So B is inverse sine of that whole thing. I'm not going to write it again. So angle B comes out to 40.5 degrees. And now that you have 2, angle A is equal to 180 minus 40.5 minus 111.8, and you get 27.7. There might be a 1 decimal round here because on the original workbook I solved for A before B, but angle A equals 27.7 degrees. So you solve for angle, and you solve for the greater angle first. So that's the cosine law. You do the cosine law to get an angle, and then you use sine law for the rest. Remember, side, 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 you're solving for the largest angle first. All right, now, if you have a side angle side triangle, We're not solving for the largest angle first. We're now solving for the smallest angle first. Okay, so we have a triangle that is angle, we got side, angle, side. So let's draw this thing. We got side angle A about 50 degrees. So that looks pretty good, except it's not what I want. There we go. Boom. Boom. And then boom. Okay, so angle A is 50 degrees, which means that's A. So it means we have an A here. B is 12, and C is 5. Okay, so C, B. Now in this case, we have to solve for the smallest angle first. How do you decide which one's smaller, angle B or angle C? Well, which side is bigger? Since side B is bigger, it means angle C is smaller because its side is smaller. And again, we have to use the cosine law. But what information do you know here, right? You're solving for angle C. So we'll start by solving for side A, because once we have side A, we can then solve for angle C. So we're going to go A squared, because we can't do cosine, or we can't do sine law here because we're missing an angle, right? We have a the angle we don't have a corresponding side. So first we have to solve for A. So A squared equals B squared plus C squared minus 2BC cos A. I have all that information. So A squared equals B squared, so 144 plus 25 minus 2 times 5 times 12 cos, and I have A is 50 degrees. So A squared equals 169 minus 120 cos 50. Do not do 169 minus 120 first. Remember, this is BEDMAS, this is multiplication, so you have to do that first. So A squared comes out to be 91.865. A is the square root of it, which is 9.5846. And in this case, we can round that to 9.58. So you got A. And now that you have A, you can use the sine law. But we're solving for C first. Okay? So sine of A over A equals sine C over C. Multiply both sides by 5, and then use your inverse sine, and you get that angle C is equal to 23.6 degrees. And now to get angle B, it's just the 180. So 180 minus 26.3 minus 50, angle B comes out to be 106.4 degrees. So the two caveats for cosine law, and you'll see on this page right here, is if you're given a angle side angle or an angle angle side, you use you can use the 180 to get the missing angle because you already have two angles in both cases, and then you use sine law. If you have the ass triangle, remember you got to check the ambiguous case, and then you use law of sines. If you have side angle side or side side side, you're using cosine law. But if you have an SAS, I don't think James Bond, Secret Agent Service, you're solving for the smaller angle first. And if you have side side side, largest angle first. If you forget to do that, you're going to be in a bit of trouble. Okay, that's it for cosine law. So practice away, and we have one video to go.